So basically we have a spool of optical fiber. Take the lid off. This lid is just basically protect the optical fiber from dust and dirt. And just a precautionary, we're going to use the optical connector cleaning tool to clean it first before we will plug into the optical time domain reflectometer. Just press that, and it's one direction cleaning. Do it lightly, don't need to press it that hard. And now we will plug into the laser output. Remember, this has to be turned off first. Turn on is when it lights on red. So right now there's no light on at all, so that means it's off, which is safe. Pull up the flap and plug in your optical cable connector. Tighten it. Yep. That's good. And now we turn on the laser. As you can see, it turns red. And there you go, you get a reading. Basically what you're seeing right here, this spike right there shows the laser hitting into the optical fiber, causing that spike. And that spike over there is basically the end of the optical fiber cable. That's why it's giving us such a high spike, releasing into the environment. And now I will show you how to measure it. Like I said before, loss of attenuation is measured between 2 points, and the given point is X and asterisk. So what we want to do now is make sure that we are set onto loss, then spice, and that we are connected with LSA rather than 2 points, and the average on. As you can see, the average on right now is clearing out the graph as we see. Okay, so now we're going to move the X marker to the point where we want to measure. Right now, as you can see, I get control of the X pointer, and using this rotary knob I get to move it down. Basically, as you can see that spike right there, we want to measure the point where it comes right back up to the top, measuring from that point. There we go, up there, which starts at around 0.04 kilometer. Pressing the marker again, we will get control of the asterisk. And now we're going to move that to the next spike. We move to the point where before it jumps to the top of the spike. There we go, jumps to the top, so we don't want that, we go back one, there we go. Now, that is between the 2 points we're measuring. And as you can see here, it says loss X minus asterisk, and it is around 4.1 kilometers. And we are having around 0.58 decibels per kilometer attenuation. And between that 4.1 kilometer, we have a total attenuation of about 2.4 decibel.